Welcome. This is an analysis of a very common matter. Most colleagues I've worked with in the SysML world have sooner or later encountered this problem. If you're going to work with custom extensions of the SysML block stereotype on a project of any complexity, then this video is for you. Please note this is a presentation by Webel IT, not from the tool developers. It's highly recommended that you read these MagicDraw help pages. If you are watching this video, you've likely already played with stereotypes. We will be looking at customizations during the video. Note that those help pages are about UML, and we're looking at a specific SysML case, namely extending a SysML block stereotype. Firstly, a disclaimer. This screencast is not intended as a tutorial. It is not structured like a tutorial. Nevertheless, you may learn plenty of useful things from this video, and it also has lots of good modeling tips in it. It is necessarily quite long because the topic is subtle and tricky. So we're going to look at what happens when you try to use domain-specific extensions of the SysML block in combination with basic inheritance. And ultimately, this concerns fundamental conceptual challenges, not underlying problems with UML or SysML. We're also not doing any advanced domain-specific language element customization. We're only doing just enough to examine use of custom stereotypes in combination with inheritance hierarchies of blocks. At just over 1.5 hours, this analysis video is long. It is not intended that you watch it all in one session. In any case, you may need tea or coffee or beer or wine. And remember, we choose to study MBSE with SysML and do the other things not because they are easy but because they are hard. We are here to do the hard stuff. Okay, here's the formal definition of stereotype from UML. Stereotypes can be used and abused for many purposes, including the two situations we're going to look at today. Indicating cross-cutting aspects of a model, such as membership within layers of a modeling domain. And carrying per element metadata as tagged values. And this is the one especially where people tend to get into trouble, because element here means strictly a UML or SysML element. And that's where complications can arise when you have an inheritance hierarchy of blocks and when you are using SysML internal block diagrams and block structure with part properties of blocks in combination with tagged values for carrying metadata. Before we look at applying stereotypes and other alternatives for doing it to block hierarchies, I'm just going to show you the big trick. You see, people might ask themselves, since we are doing SysML, shouldn't I be specializing block like this? The stereotype extends block. Now, for some things, that is what you want to do. For your classic DSL stereotype, which is essentially a new kind of element as an extension of block. But if you're doing something like using stereotypes to indicate cross-cutting layers in a system, you find that you will get trapped doing it. You won't be able to apply them multiple times. To apply this type of stereotype, you have to in fact use the refactor element if you're applying it to an existing block. And if you set up hide meta type true on your customization, then you can also access it as a new element from context menus. Now we are going to look at that in detail later, but firstly I'll just show you how you can apply layer type stereotypes multiple times. So here I have a security layer, a network layer, and they have customizations here, security layer, network layer with keywords security and network. Now I've got security layer directly extending, that is an extension, which bridges between stereotype and metaclass. I've got network layer extends class, and I've also got them extending data type and property. So we'll be able to indeed apply these still to blocks, which extends class, to value types, which extend data type, and in any case to properties and port, because port is a special case property. They are the typical elements you might wish to apply their stereotypes to. Later we'll see that the easiest thing to do is simply extend element and not fuss over it. It gives you all the choices and you don't lose much. Right, so down the bottom here, we're going to experiment with applying those. Now, as always, when you create your customizations, you must remember to close, then reopen your project for them to be applied. Before we look at applying them, I've marked this with a warning. It's not, in fact, the wrong thing to do, but it's not well advised for the layer type stereotype. We have here a keyword extender, so we can track application of that one as well. Okay, so let's have a look at applying them. We'll start with our extender one. To apply it, you cannot simply find it here. It's marked as a block, and you'll see that extends block is not offered. That blocking is part of the machinery of the implementation in the MagicDraw SysML plugin and Cameo. Right, so I can convert the element to extends block, and then we have our extender keyword. So it's treating it as a separate, distinct DSL element. Right, but what you can't do then is apply such stereotypes multiple times. You can only do it once. Whereas the other ones, which extend a class, data type, property, we can apply multiple times. So I'll just do it with value type first, just get that out of the way. I can apply, for example, a network layer, and it may also be involved in a security layer. If you have something that has implications for both aspects of a project, you might like to do that with your value type. So we see that it's not clashing with value type because it doesn't specialize value type. It is extending data type, as does value type. Right, so we can do the same here with the block. We could say that it is involved in the network layer and security layer, like that. Now we can also do it with ports. I strongly recommend that you do not permanently display port symbols on block definition diagrams. I know you'll see it everywhere else, but I like to list them. You can do it temporarily using these guys, and you can display symbols, which we'll look at. But I like to just show the port symbols in IBDs and structure compartments where you can in fact connect them up. Right, so what we're going to do is we're going to apply stereotypes to these. So assume that the ports have some implication for both security layer and network layer. So I can choose that guy and apply stereotypes. Now you may not see them both initially unless you have the symbol property set to show port stereotypes. And you can see them. So I'll show you the way using the little port symbols, display ports. You see here I have a standard port. Because you are allowed to use standard ports in SysML. A full port and a proxy port. A bit of a room here because we're going to expand them. Now, there's a trick I like to always show because I like doing it this way. Port display mode, I'm going to find it. Here, position of labels. Name and type of labels inside. However, it will not automatically show the stereotype that way. What you can do though is enable part compartments, which, as I always emphasize, really means enable SysML compartments. And then any stereotypes we apply to that will appear if we also show stereotypes. Show stereotypes text. Okay, let's do it with these guys. Now, in this case, you've got additional stereotypes there, full and proxy. But you'll find, because of the way we've set it up, they will not clash. We can happily apply network and sec to that one, and same here. Network sec, and you can see this. The thing is, if you've got flow properties, the disadvantage with this display mode is you lose the flow indicators. But if you're just dealing with contract ports, it's really much easier to do it this way. You don't have to worry about the alignment of these guys. So do it with this one first. I'll just go straight to enabling part compartments and enable part compartment. All right, so you see there we've got the ability there to apply multiple stereotypes. I seem to have missed the sec one on there. Security layer. Okay, so that's the way you can have your cake and eat it if you're applying layer stereotypes. So next we're going to look at what happens if you don't do it that way, if you extend block, and we're going to look at it in combination with a block hierarchy. Okay, let's look at the setup. I have here split pane layout. At the top, I have a profile with stereotypes for layers of a building. And we're going to apply the stereotype to some of the blocks here. But for some of the blocks, we're going to use a different approach. For some of the blocks, we're going to use value properties of an inherited block instead to indicate the layers. And then we're going to compare the two approaches. Okay, the first thing to notice is that we're going to be just indicating cross-cutting aspects without any tagged values as metadata. So we're not using any properties on the stereotypes yet. I have an abstract stereotype layer, which is specialized by these concrete stereotypes that will indicate the layers of the building. A layer is a specialization of block. So that's a generalization relationship. And this is an extension relationship which bridges between a stereotype and a meta class. It's important to notice that these, in fact, if set up correctly, also have extensions to class. You should make sure that the meta class here is indicated as class. Now, one of the reasons people like to use DSL stereotypes is that they may carry an icon. I've only set it up here for the electrical layer, but you could imagine setting them up for each of those easily. For now, we're also going to assume that our layer is just applicable to block, which is classifier. We could also, for example, specialize value type so that it's applicable to value types. We could also make it applicable to properties, so it would be applicable to a part property. But for now, we're going to apply the KISS principle, keep it simple, and then we'll look at the other cases later. Now, I've also created MagicDraw customizations corresponding to each element. You can see I've created a mirror effect here. That's the pattern. Now, I'm not going to go into customization in a lot of detail. We've covered that in other videos. It's also covered in the MagicDraw help pages that are referenced at the beginning of this video. Just a couple of things to note when you do it. Firstly, remember to always close and reopen your project after creating or changing customizations. I have here, just for consistency, a customization matching layer. And then I have matching the inheritance of the stereotypes above the corresponding customizations. Now, it's very important that you extend, ultimately, the block customization. But as far as I can tell, some of these are inherited as you would expect, some are not. For example, category, which defines grouping in context menu, does not seem to be inherited. So I have defined rather tediously a category layers for grouping each of these. I've also explicitly defined hide metatype. They each have a keyword, which is how the stereotype displays in guillemets. Not sure if that's how you pronounce it.
Guillemets.
Those little guys.
Guillemets.
When you apply the stereotype. It's instructive to look at the customization for some of the non-normative extensions, such as domain. That's sufficient to get you started. Right, and on the block customization, I've only shown some of the tagged values here of interest to us. There's actually quite a lot, otherwise it displays quite wide. The possible owners package, model, profile, and block are important. They define where the context menu will be offered for creating new elements. So if I hide this guy, go to a package, I won't actually do it, I'll just show for now. Create element, and there is a group here, now layers, where I can create my layer blocks. Now let's look how we're going to apply them. You might have noticed that I have set up here nice navigation points to, in this case, a block definition diagram and an index page. The diagram is also, for convenience, down here. I have similar cross navigation set up there, so I can move back and forth between them. However, if you have the split pane approach, all you have to do is double click there and then zoom. Okay, we're going to look at this very carefully, very slowly. So do please be patient as I explain exactly what we're looking at. Don't be overwhelmed. We're going to go through each part very carefully. Okay, so we're going to look at applying the stereotypes to blocks and to blocks that type ports on blocks. But we're also going to look at how we can achieve something similar, at least in the case of indicating cross-cutting layer membership using value properties and a regular SysML model. Okay, so on the left-hand side here, I have the blocks that we will be applying our layer stereotypes to. So for example, I have here space that happens to be abstract, server space, and public space. And I have some types that will be typing ports. I'll say a little bit more about that later. Over here, I have a different approach. I have an abstraction layer object. I have an abstraction electrical object. And then I have a block and a port type, another block that we'll be using to compare with the stereotype approach. So they won't have the stereotypes applied to them. And we're going to use them both as blocks and as parts of blocks, because it's very important to see how the information propagates. This block over here is going to be treated the same as these blocks. It's to say it's going to have the stereotype applied. Now, just look at some of the other aspects of the setup. This is of general interest to your SysML modeling. Firstly, I have I might see if I can move that guy. Firstly, I have a voltage value type that's predefined in this ISO model library. Now note, you can't stereotype this with, for example, a layer indication because it's from a read-only model. But it would be nice to not only stereotype blocks with our layer indications, but also to stereotype other parts of the model, such as custom value types. We will look at that later, but for now, we're just going to look at stereotyping the blocks. Okay, so we've also got here flow property and a value which are typed by the voltage here and amperes, which is also from the model library, not shown here. And I've given these default values and I've marked them also as read-only. So the idea is here we're going to have a generator outlet on a generator and a switchboard with a voltage that is able to cope on the main bus with the voltage from the generator. Now, the whole idea behind our electrical object is that we can indicate the layer and reuse the indication of the layer for all objects that inherit from electrical object. We'll look at exactly how that's going to be done a little bit later. Firstly, let's look at the stereotype approach. The consistent way of applying our block extension is to use refactor, convert to more specific, and choose it there. Now for the moment, I'm only going to apply it to the top level items in our hierarchy. because we're going to see that there's a weakness in this approach, namely that it's not automatically inherited. I don't quite like that word for stereotypes. It's not immediately known by the subblocks. Have to remember to do this guy here too. Okay. Now, before we do anything exciting, we're just going to look at what happens if we use that in another context as a part property. Because ultimately, any single thing we define is going to be used in a real-world project as a part in an internal block diagram or the structure compartment of a higher level context block. So let's activate the structure compartment here of this guy. I'm just going to place that in. Be careful to get the right spot. I will close that off for the moment. All right, now, this is a very important subtle point. Stereotype display is off on that guy for the moment. If I go to the symbol properties, show stereotypes on. Now what we have there is what is often called a secondary stereotype. It's showing through from the classifier because I don't have a property level stereotype applied. Now, if I were to create a property level stereotype and apply it to this, it's going to hide it. So think about what that means. It means the entire idea that we can use a block extension stereotype to indicate the layer membership of a part property has been undermined. If I go back here now to layers, and I'm going to create a big stereotype property level. So that will include, if we set the meta class on it, the property, that will also in fact enable us to cover ports as well, because ports are a type of property. So I go back now to our experiment, and now I'm going to temporarily hack it. Property level. Gone. We can no longer see the layer stereotype applied, although it is there on the block that types the part. So once again, we see that stereotypes are per element. A part property is an element of the model, and this is one element. It's a block, a classifier, and that is a part. Part property is a different element with a unique existence in the model, so I can apply different stereotypes to it. All right, I'll just undo that. We can see the weakness. We're going to use that again in a second. All right, now let's look at an alternative approach, an approach that's compatible with a wide range of SysML cases. Just for this case of applying layers, just for this case of indicating layers in our model. So what I'm going to do is now look at the layer object and electrical object. So a layer object is a high-level abstraction, and it says that each object in our model has a layer kind. Now you might be thinking, if you're from a software background, that this is not going to scale because we're going to have to use multiple inheritance. And if you are from a software background, you may have bought the myth that inheritance is evil and that multiple inheritance is even more evil. Now, we are not doing software engineering. We are doing systems engineering. And in SysML, you can inherit as many times as you like from as many things as you like. There are issues when you do it that you have to deal with, but they are not the same issues that you have to deal with in software engineering. And by the way, inheritance in software engineering is not evil if you know how to do it well. But that's for another day. All right, so we have a layer object. And we have an electrical object. And we're going to give it a specific layer kind. Now, the manipulation for this for different operating systems, I'm going to do it on a Mac. So you hit the Option key, it turns into a plus. And now we have a layer kind here. You have to be careful with the multiplicities. I've said that, in fact, a layer object can belong to more than one layer. For example, we have a switchboard. We may wish to indicate that it is electrical by nature. However, a switchboard could also, for example, be implicated in the fire protection layer. So I've left it open that you could have more than one. But our electrical object is going to, for the moment, be bound to a single layer type first, which is going to, of course, be the electrical layer. So let's look at the value type we've got here. This is actually an enumeration with a SysML value type stereotype applied. The reason I've done it that way, and it's also done that way in the tool by default, is so that when you apply it to a block for a value property, you get a value property, not a UML property. If you take it off the menu there, you'll see that it's in fact giving you an enumeration that is a value type. All right, so our layer kind has these different layer indications, which are exactly the same as the keywords that we used in the stereotype approach. Okay, before I forget it, what I want to do is set that as a redefined property. So we're going to redefine the property's multiplicity, and we're going to set the default value on it. Now, I appreciate that this doesn't look very convenient compared with the stereotype approach. However, because you can inherit it, you only have to do it once, and the tool makes it quite easy. All right, let's do a little bit of diagram shuffle here. Move you across, sort that later. Room. Okay, there are different ways of applying a default value to it. You can do it through the specification dialog. You can do it using drag and drop. However, we have to remember to set the multiplicity to 1, and we have to set it to read only. Okay, let's pause and look at what we've got. Anything that is an electrical object now knows that it has a layer fixed to be electrical. So these guys are going to have that value always. Just show you that you can see that on a block. If I go to symbol properties, show inherited, Now, ultimately, we want to be able to see this information on part properties. So let's look, for example, at our generator. If I might need to shuffle to make some room to do this. If I put you in there, it is now of type generator. Now, I'm not going to show the stereotype on it because we're going to look at a different way of indicating the layer membership. SysML has special compartments for showing values defined on the classifier behind it. Okay, if we use these compartments here, we can see values defined at the classifier's first level. There's a slight catch here. You need to show inherited on the part. Okay, let's just make a whole heap of room here. I'm going to need some room. Normally I would advise that you do this in an internal block diagram, but for the sake of this screencast, I'm being lazy and convenient. Okay, so there we have it. The layer kind is shown as electrical. If I wish, I can turn off this type, make it a little bit more compact. Okay, so you can hide there the attribute type, and it's a little cleaner. Not too bad. The carré there is perhaps a little unusual for people who are not SysMLers, but I think it's pretty clear, and I recommend that you do leave that in so you know where you are.
Carrot.
Now, this approach has the huge advantage that it works together with inheritance. So I can use any other electrical object in the entire hierarchy, and this approach works. Okay, we're going to look at some more pros and cons of the different approaches. Before I do, I'm going to make a little bit of room so I can keep playing this losing game of using the structure compartment instead of an internal block diagram, just because it's convenient for the moment to do so. I am going to have to make a bit more room. All right, so let's now create a block HiGen, which is going to be a futuristic hydrogen power generator. We can swap the type of that to be a hydrogen generator, and the layer indication stays the same. Right, now let's have a look at another electrical object, but this time we're going to use the switchboard, which also has this other information, just so we can see a slight disadvantage of the recipe. Okay, we show the values, then we have to do our other display adjustments. Show inherited, hide the attribute type. Move it all in. Okay, so that now demonstrates a slight con of this approach. The information about the layer it belongs to is now together with general information about the block behind it. So in a sense, we're conflating cross-cutting information with true model level information. Another disadvantage is the fact that we can't show icons easily this way. With a stereotype approach, if we go to symbol properties, show stereotypes, text and icon. And we can also do that on that one. Okay, so I'll activate that on these guys as well. Now, it's time to look at one of the big disadvantages. That's it right there. If you know me, you'll know that I think that breaking single source of truth or the don't repeat yourself dry principle are the two greatest sins in the IT and systems engineering world. This requires that we break the single source of truth a little bit. We have a maintenance problem. We have to remember to apply that layer every time we inherit. Now, it's not too bad. We only have to do it once. And something like a layer indicator is something that we're not probably going to have to do too often. But it's definitely a con. It's definitely a maintenance problem. We're going to have a quick look at attempting to assign two different layer indicators to blocks using the two systems. Firstly, using the stereotype approach. If I just try to apply the stereotype using this dialog, for example, let's say that the electrical service room is also part of facilities, I can't apply it with our current setup. Just look quickly there at our current setup. Electrical and facility, both specializations of the layer stereotype, and with these customizations. So that doesn't seem to work. We'll see, however, later that if you loosen up the hierarchy for the stereotype and just make it have an element as meta class, then you can do more. Right, so let's say we wanted to also make switchboard part of the electrical layer and the facility layer. Now, what we don't want to do is have here, for example, it extending electrical object and a facility object, because then you're going to get a clash on the layer property. What you'd like to be able to do is redefine the default values on that property. So firstly, I'm just going to do this so you can see that I'm playing fair. I'll completely loosen up the multiplicity. I'll make it unspecified, we'll do for now. Now, as far as I can tell, there is a bug here. If I choose the default value, it is supposed to be a value specification. A value specification can be a set of values, possibly null. It could have more than one value. But at the moment, what's got there is in fact an instance value, a single instance value. If I delete that, it then just offers me the literals. I can't seem to find any way to do multiple select on them. And under value specification, I only have these options, and I have tried them, and I can't find any way of assigning more than one enumeration literal. So, result, that approach fails. I'll just undo it all for now. It's time to look at ports. Now, firstly note I'm not using interface blocks. Okay, so I have a type with my convention, capital F underscore, for a type that will carry flows. And I am going to apply it to these spaces. Now, the public space is going to get a safety power socket port. The server space is going to get a regular power socket. Okay, so on the menu, I'm going to grab a regular port. Ignore all that for the moment. Just make sure that's a safety one. I'm going to remove you, and then we'll put a regular one on here. A regular power socket. Okay, so if we now choose to show the stereotypes on this, show port stereotypes true. See, it's not showing the stereotype from the underlying type. And this guy as well. All right, that's because the stereotype is applied to the type of the port, not the port itself, where the port is a property, special kind of property. All right, now if we go back to showing that symbol, I guess symbol properties. See that it in fact does not show the stereotype. So this is the same weakness we've seen earlier, that the stereotype comes with a maintenance burden. We would have to have the stereotype also applicable to a property or port type and then apply it each time. So you're not getting propagation of the layer stereotype applied to the classifier. Right, now let's compare that. Move these guys across a bit. With, say, our generator. We want the generator to have here the generator outlet. So, regular port. I'll leave the symbol on there so we can see them both. Right, so what we want to do is expose this layer information. If I Select that and go enable part compartments. They're in fact not just part compartments, they are SysML compartments. The menu item is not ideally named. I can then show values on it, but I have to show the inherited values as we did before. And I'll turn off the attribute type just so it's concise. Okay, so let's tidy this up a bit. Now, I do not in fact like showing the support symbols on BDDs. I like showing them IBDs. I'm just doing it here for convenience so we can see them side by side. So I'm not suggesting you mimic exactly what I'm doing here, but you can show these exactly the same way in an IBD. You can also show them on the boundary of an IBD. Okay, so there we've got our layer indicated very nicely. And there's no maintenance issue because it propagates from the type. I'm just going to tidy this up quickly so that we have room for the next experiment. Plenty of room there. We can use this same SysML compartments trick on this. If I go enable part compartments, now place it down there, we'll be able to see. Now we can see that the secondary stereotype is shining through from the classifier. Now there's some pros and cons of using this display form. Notice that we have lost our flow property directional indicators. And also, if I now convert that into a proxy port, if I go refactor, convert to proxy port, the property level stereotype proxy for proxy port has covered up the classifier level electrical stereotype keyword. Same problem we hit before. The only way around it is to open up the stereotype so it doesn't just extend to block and then can be applied to different element types. However, it is breaking the single source of truth principle. It is a maintenance problem when you have lots of ports. It's time to look at tagged values of stereotypes as metadata. I've quoted it because it's not always clear what's data and what is metadata. Now, the following shows some serious abuse and misuse of stereotypes as tagged values, especially using tagged values to carry data for most kinds of physical values is strongly discouraged. The takeaway is that trying to use stereotypes to carry some kinds of data, especially in combination with complex block hierarchies and with part properties and ports of those blocks, leads to confusion and maintenance problems. So why do people do it? Many of my colleagues have done it. I even used to do it sometimes. The reason people are enticed by stereotypes is they like the display capabilities. In fact, in many cases, you can achieve both superior maintenance and display of values specific to parts in block contexts using the context-specific values mechanism applied recursively across a context-rooted hierarchy. We won't, however, be covering that in this presentation. Another reason some users like to use stereotypes everywhere is to help filtering when generating tables and reports in the tool, which is powerful but does have some limitations. Don't concoct a modeling recipe just to suit the report extraction. This is putting the cart before the horse. In fact, the most powerful and essentially unlimited model data extraction can be achieved by creating a Java plugin. We're going to use relatively abstract cases to permit tracking of propagation of metadata rather than real-world examples. We have here a profile which we'll be applying to different cases. We have a stereotype we can apply to any element, and a stereotype we can apply to blocks, value types, and properties, which includes port. Okay, this presentation contains some serious tagged values abuse. In particular, I've included as a provocation a length, completely at random, used as metadata, as a counter example. Here we have a length attribute in the apply to any stereotype. Note also that I'm using value types, SysML style. We have a string, which is for a more metadata-like tagged value, an ID. And this one is indeed inspired by a real-world example. In infrared astronomy, you have frequency bands, and you might wish to indicate the frequency operation band of components as a cross-cutting indicator across your model. All right, so we have this other stereotype, which we can apply to a block, value type, or property. We have customizations for each. In this case, we have a keyword any to make it easy to follow. And in this case, we have a keyword BVTP, standing for block value type property. Now, to avoid confusion when we apply the tagged values, the attributes are respectively prefixed by their keyword. For example, any band, any ID. BVTP band, BVTP ID, to enable tracing of the tagged values at different levels in our model. Now note we are not setting hide meta type to true because it's not intended that these be used as standalone DSL elements. The idea is that we are adding metadata as tagged values to a wide range of element types. We're also deliberately not inheriting, this time, from block or value type customizations. I've noted here, especially concerning the use of the physical length as metadata. The reason people often try to do this sort of thing is to try to get application of physical information to parts with a particular context at different levels in a structure hierarchy. Instead of doing that, mostly you should be looking at context-specific values. Not going to be covered. I'm just noting it. That's what you, in most cases, should be doing. So we're going to look at what you should not do most of the time, but some people attempt. Okay, here are the cases with some of these stereotypes and some tagged values already applied. Get a cup of tea, or a coffee, or a glass of wine. We're going to go through this bit by bit carefully. This is going to take some time. That's why I'm doing it. That is why you are here. We're going to look at one of the most complex things you'll ever encounter in SysML and in any modeling of any kind. But we are doing the hard stuff. Firstly, I'll start with this interface block. Now, just because it's an interface block does not mean you can only use it with a proxy port. It is, however, primarily intended for use with proxy ports. I have applied the any stereotype to the block. It is using the Webel convention for a contract of I underscore. We have some metadata applied. Any band equals A, any ID equals I underscore C. And if you've never seen how to do that before, the dialog for it is not so convenient, but you go to tags under specification, and there you can find the different stereotypes. You can filter them by your profile. So for example, that would be cases. It's a little easier to find. And then you can apply them. Now, a length has no meaning, probably, for most interfaces. I'll put a value in there anyway. The ID, that's a more sensible use, more metadata-like. And we had our idea of a band. In this case, it's indicating that the interface deals with information across a certain frequency band. We also have a custom value type, and we've also applied the any stereotype to it. See here that in this case we've got the tag values applied using the tag values compartment form, and we've set any band to C and the ID to CVT for custom value type. I'll just show you that if I right click on that, go to stereotype, apply to any appears, but the other one, apply to block value type property, does not appear because I've got value type selected. For the moment, I'm just going to leave it like that. Just noting that the application of value type masks the other stereotypes in the same way we saw before for block. Okay, then we have our super block, meaning parent or super, and we have two subblocks, a subblock with no stereotype applied and a subblock with the any stereotype applied. Right, so we have applied the stereotype any here to give any band equals A, any ID, and a length. We note again that using the length as metadata is intended in this case as a provocation, a counterexample. There may be cases when using physical data is sufficiently indicated. In most cases, however, there are better ways of doing it. We also have here a value property, which is of this value type. It has metadata showing by virtue of the applied type. So this is a secondary stereotype. This is secondary metadata. We're going to see later that when we apply a property level stereotype to that value, that it's going to hide these tagged values as well. So I'll show it now. We're going to show it, then undo it to get the idea. If I go to tags, just put in values here that are different, go to any band, create value. I'll change the band to D. Watch it carefully. It looks as though the same stereotype has been applied. But in fact, what we saw before was the application of stereotype to the type. Now it's applied to the value. And the tagged values are showing the values for the value. Let's undo that. There. Okay. We have some ports. Now, I haven't shown them on the boundary of the block. I do recommend, even if you temporarily create ports on the boundary of a block, that you just list them in compartments and use instead structure compartments or internal block diagrams to show your ports where you can in fact connect them up. If you can't connect them here anyway, I strongly recommend that you just list them. Now we have 4 different cases of ports. I have a port where the type is stereotyped, but the port is not. I have a port where the port is stereotyped, and it has here specific values. And in this case, we can in fact have both of these stereotypes applied. There is no masking. We have the same, but as proxy ports. So we have a case where the stereotype has been applied at the port level, and we have a case where there's a stereotype applied just to the type, but it's a proxy port. So if I look at stereotypes, you'll see that it is a proxy port. There's no other stereotype applied to this one. Whereas this one is both an any and a proxy port. Now in the subblock, we also have a custom value that is redefined. So it has a different default value from the one in the parent block. This other metadata that is showing here as tagged values is in fact from the underlying custom value type. All right, before we go any further in applying them, it's so simple, and yet people do sometimes fight against the reality. Applied stereotypes carry tagged values as metadata per element, so there is no sense in which the tagged values metadata is inherited. There are good reasons for that. People sometimes complain that this is so, but it is a misunderstanding about the intention of stereotypes and tagged values. And it is a fundamental conceptual challenge. It is not a shortcoming or problem with UML or SysML. All right, let's look at some applications of them. I have here a part in a context block. This is what we're focusing on. Remember that blocks are just definitions to be used in a particular situation. Ultimately, our real-world model has to use parts in contexts. So I'm using the SysML values compartment here. If it's not available, you use enable parts compartments, but in fact shows SysML compartments. So we can show on there values and other aspects of the underlying classifier. I've also shown this value with its default value as a symbol in the structure compartment. And we have the ports. Now you'll notice that I'm showing the port label along with its type inside the rectangle. I find this very convenient, except when you have flow properties, in which case you can't see the directional indicators anymore. And it turns out if you enable the part compartments on that, which might be better named enable SysML compartments, you get this form anyway. So I'm going to do that just so we can see the difference in the representation. We now see the secondary stereotypes shining through from the type of the port. Now you can disable secondary stereotypes. I'll just see if I can find where that is. Show secondary image and stereotypes do not display. I'm going to undo that so you can see that they can in fact be disabled. Right, now none of the tagged values metadata that was defined on this contract block are available for display here. As far as I can tell, there is no way of doing it. If you look for tagged values, you can turn them all on. I'm just doing this for point of demonstration, that they are all on. Whatever there is to turn on has been turned on. You cannot show them. Now the next guy has stereotypes applied at the port level, which is a type of property. A port is, in fact, ultimately a special kind of property. Now, because there's no blocking by other SysML stereotypes, because both any can be applied to anything and a BVTP can be applied to properties, which include ports, I can apply both. So I have here sets of information for any and sets of information for BVTP. Now, to be kind, because this is all confusing enough, I have set those values to be identical. You could, in fact, set the tagged values to separate values. So the demonstration makes deliberately achieving the single source of truth and don't repeat yourself principles a bit tricky to enforce. Right, so that representation visually is a little difficult to maintain. You can see that that can all get out of sync and out of sync with these labels and the rest of it. So if you're not interested in showing the flow property direction indicators, if you're dealing with flow properties, and in this case we have a interface contract type, so we don't have flow properties, that is your best friend. So what I've done there is enable the SysML compartments. Now, we have our tagged values shown in this form. There are options for changing the way that's displayed, but that will do for now. Okay, so we'll do the same with this guy. Enable part compartments. That is a proxy which has the stereotype. Aha! The proxy port keyword hides the secondary any stereotype keyword. So, all the effort that went into the tagged values for your contract is now somewhat wasted because it's not visible at this level. And here we have the tagged values at the property level. So we have both proxy and the any stereotype applied, and we are carrying port specific tagged values. Now I've deliberately set these to be different from the interface contract. This represents an override. Now it is in a sense anathema because you can't see the tagged values from the contract anyway. But just to be completely thorough, I've got the any band here set to D, whereas on the interface contract it is set to A. I've got the ID representing the property, the port as a property within its owning block to have this identifier. That's a sensible use. And then we have this strange length thing, and I've set it to a value 9.87, which is different from the whatever value it has there. And now to make it easier to see, we again put that there. I'm going to have to do a little bit of bumping here. Something like that will get us out of trouble for now. Okay, let's just look carefully at what we've got. A port, the type of which is stereotyped, the tagged values from the type as metadata exist in the model but cannot be shown easily, as far as I can tell, in a usage context. We have a port that is stereotyped explicitly and can carry tagged values metadata, and both of our stereotypes are applicable. The one that applies to all elements and the one that applies to properties. No masking. We have a proxy port where the type has stereotype applied with tagged values, which cannot be displayed. And then we have a proxy port where the any stereotype is applied and it has tagged values applied. However, if I go to stereotype, I cannot apply our stereotype that applies to properties and therefore also ports. Why? Because proxy port has masked it. So let's think about what that means. If you want to use proxy ports or full ports in your project and you wish to use stereotypes as cross-cutting indicators or to apply metadata as tagged values, you have to be careful that your stereotypes do not clash with proxy port, full port, etc. So it turns out that trying to be tricky by extending block as well as property or value type as well as property doesn't work. And it turns out it does not matter whether you set hide meta type to false or not. It'll still cause a clash. So you might as well either just extend class and property if you wish to restrict it somewhat, or you might as well just open it up completely, as in our apply to any example, and extend element. You can see here also, you might like to stop the screencast briefly and inspect these diagrams, that I've shown the cases that do work in parallel with proxy. And the same, of course, applies to full port. Okay, let's look at these other guys. I've got here a subpart which is explicitly now stereotyped. I've applied the any stereotype to it. So it now has any band equals C, whereas the type had any band equals A. The any ID, sup part stereo, sup PS, that makes some sense to apply. It has this strange length guy. In this case now at 3.2.1, and on the block it was 1.2.3. Now I'm not showing ports on this because we've covered that. There's nothing else to show concerning the ports. We are looking at the values. Now, have a look at this one. There's our value shining through from the classifier using the SysML compartments. There's the value with its default 1.23, and the value is showing through. So SysML is giving us there a robust way of propagating information from the classifier to the part. And you can even get in there and edit it. And there it has changed. So that's more convenient than editing tag values by a long shot. And you've got the display power. Just undo that. Right, we have also our sub-block stereotypes. Now the sub-block that had no explicit stereotype applied has not inherited any tag values. And what do we have to display? Nothing. We have no access at all to this information that we invested effort into putting in. Wasted. Whereas this information can be reused. In fact, I can show on here values, and if I make sure I show inherited, there it is. Consistent reuse of the information. Whereas this information can't access. No use to me at all. Now let's look at the case where we have a redefined value property. Here we are showing the redefined value in a part that has this type, and it's relying on the type of the block to try to show the stereotyped information. But I can't get at it. It's of no use. This one has a part level stereotype applied. Here's our any. So there it's a secondary stereotype. There it's direct. And it then overrides. Any band equals D. Any band equals B. Any ID. Any ID. Any length. Any length. Different values. Okay, so that again is a sensible use here of the ID. That one slightly contentious. You could do it better as values anyway. This one almost certainly a bum steer. We said we'd have a look at applying tagged values as metadata to a value property. And most of these tagged values don't make much sense for a value, but we'll do it anyway. So just to recall, these tagged values are in fact showing through from the type that types this value property. So we might like to call these secondary tagged values. However, if we now apply some values to these, let's stick anything in here. Call that band D. Doesn't make any sense. This might make more sense for a value property. So let's say value within sub block, and putting a length on a length definitely doesn't make much sense, but we'll do it anyway. I'll do it. And let's see how they display. Okay, so we now have the tagged values that are specific to this value property, and it now shows the explicitly applied stereotype. We can also see that on this guy. We might have to do some shuffling here quickly. See, that's not going to work. Like that. And here. Excuse me while I shuffle. Okay, so they're also displaying here. You have to make sure that you have here show attribute tagged values. If you toggle that, you'll see that you can turn them on and off. And it's also showing the stereotype because we have that displaying for attributes. And they also appear here in the version where it's shown as a symbol. They show also on this guide here by virtue of the fact that this value is inherited into there. And note that because this value here redefines that value, the tagged values we've just applied do not appear in these ones. We're now in a position to understand something important about the different ways stereotypes can be used. We could take something like this guy, value type, and we could, if we wanted to, refactor it using our apply to block value type property stereotype. It's a bit confusing, however. Let's go back and have a look at the original cases setup. We've got this guy that specializes block, value type, and extends property. Now you might ask, why would you want to do that? The reason I think people try to do this and then tack on metadata is they've seen those non-normative stereotypes: domain, system, subsystem, external, and so on. However, those are not really intended to carry metadata and be applied to a hierarchy. They're intended as standalone elements that don't necessarily participate in a block inheritance hierarchy. There's no reason you shouldn't just use a simple metadata carrier. So this is not acting as a DSL element. So the takeaway is create a stereotype to carry metadata as tagged values, or create a stereotype that acts as a DSL element and is a specialization of block. But don't try to do both. We're going to have a very quick look at how to use context-specific values. They're otherwise known as initial values. I've never liked the term because they are not necessarily time-related. We'll see how they work. Okay, so we're only looking here in an internal block diagram for a block context at these parts that had part level stereotypes applied to carry metadata. Remember, we could sneak in here a length. One reason people might try to do this is to try to get part-specific values in for the length. You see, if I have, for example, this value here, default value, you've got to be careful to have that display option on here, otherwise you won't see it. That default value will apply to both this part and to this part. I've created another part there so we can see and compare. We might wish that value to be different within this context block for the two parts, other than the default. So what you find people doing sometimes is using tagged values. So you think, oh, I can put the information in that way. SysML has a better way of doing it. It'll only work in an internal block diagram in MagicDraw or Cameo, but if you go here, go Tools, Define Context-Specific Initial Value, we're only doing it at the first possible level, which is a simple value. And I can then type in something different. It's beyond the scope of this video to see how it's working, but what it's doing is it's storing that information in a slot of an instance that corresponds to that part. And you can play this game at any level in your hierarchy. So we can apply a context-specific value also to this guy, and it could be different. Tidy them up like this, I might be able to just override it. Whatever. Okay. So I'll just tie that up. There. We have different values for V for different parts within that context, rather than trying to get values in this sneaky way using tagged values. That's the SysML way, and it works across a complex, large hierarchy. I hope this was interesting and helps you better understand how to use stereotypes, tagged values, and value properties in combination with a block inheritance hierarchy. You can, of course, make inquiries about SysML training via the Webel site.